Hey Sharafians, Michael and Aryan here, and today we're going to be talking about a Gauss rifle. Now you may be asking, what is a Gauss rifle? A Gauss rifle is a type of magnetic linear accelerator, which means that it uses magnetic fields and magnetic forces to shoot a projectile out at a high speed. The magnetic fields in this experiment are generated by permanent magnets. The steel balls are not permanent magnets, but they're ferromagnets. What that means is that they have multiple domains within themselves that all have their own magnetic fields, but that all point in different directions, so they basically cancel each other out. However, in the presence of an external magnetic field, which is provided by our permanent magnets, all these domains align, and their magnetic fields sum up to create a total magnetic field. So the ball essentially becomes magnetized. This accounts for the force that attracts the balls to the permanent magnets and generates the acceleration that we need for this rifle.
Okay, so for our Gauss rifle, we have a 4-magnet setup with 3 ball buffers. Since our magnets are super strong, we needed a larger buffer in order for the outer ball to escape from the potential of the magnet. However, since the balls that we are using for the buffer are stainless steel and not magnetically attracted to the magnets, they are taped down to prevent them from also being moved by the collision. A ball will be released on the right side and the projectile will fire out from the left.
One of the important things to note about this experiment is that we need to make sure that energy and momentum are both conserved. Now, in this case, we know that energy is conserved, although kinetic energy might not be, because, clearly, the balls get sped up, so the final velocity is higher than the initial velocity, which means that the final system has a greater kinetic energy. However, the final system is in a state of lesser potential energy, since the magnetic balls are all closer to their respective magnets. Now, although it may seem like momentum isn't conserved, since the final ball is clearly traveling much faster than the initial ball, it actually is, since we need to look at the total momentum of the system, which includes the gun itself. Over the course of these accelerations of the different balls, the gun is pushed backwards by the permanent magnets, which means that the final momentum includes both the forward momentum of the ball bearing and the backward momentum of the gun itself. When we looked at the velocity of each ball, we could see that it was clearly increasing over the course of its trajectory, meaning that it was in fact accelerating as it should. However, each successive ball was not necessarily moving faster than the previous ball.
Despite how cool looking our Gauss rifle is, it doesn't actually fully work. While the last ball does shoot out of the gun, the impulses generated by the previous magnets are not additive. This is because of 2 things. 1, our magnets are way too strong. In order to create enough impulse to actually kick a ball out of the potential of the previous magnet, the first ball needed to have an enormous amount of kinetic energy, which we could not do. To counteract this, we created a longer buffer zone, which leads into our second problem. Our buffer balls are in the perfect sweet spot of magnetism to be totally useless. Because they are not magnetic enough, they had to be taped down in order for them to stay attached during a collision. If they were more magnetic, then it would be impossible to stack them into a buffer line, as the outer ball would push the inner ones out of order.
Hope you guys enjoyed this, and thanks for watching.